It's Captain Charles Moore, skipper of the oceanographic research vessel Algeta and founder of the Algalita Marine Research Foundation. It's not an aha moment where you just see a pile of garbage. It's very dispersed, a piece here and a piece there, but over an area larger than the entire United States. So landsmen have a completely difficult time comprehending the size and scale of the problem and the type of problem that it is. So they always think of it as a parking lot after a football game or a dirty lake with some runoff in it or something like this. It's actually the largest surface feature on the planet, the climatic feature, that is. The North Pacific gyre is enormous, and it acts like a kind of a vortex or a toilet that doesn't flush. It pulls debris from the Pacific Rim. Any piece of trash, especially plastic trash, floating trash that makes its way into the ocean, will have a hard time avoiding this area. It's just a place where currents converge and debris accumulates. And when I first discovered the problem, it wasn't even something that I wrote down in my log. I mean, I keep log entries every hour on the ship, and I went back and reviewed them from 1997 when I crossed this area, and there's no mention of any debris. This was just the act of scanning the horizon that you do as a skipper, you know, standing on deck, looking around, seeing what's there. I couldn't do that without seeing some little manifestation of civilization float by, but it wasn't, you know, a large object that was worthy of putting down in the boat, something that I might have run into or something that was dangerous. It was like a little scrap of plastic or maybe a bottle cap or something like that. So there was no aha moment, no eureka, I found it kind of a situation. It was just that this area that I crossed for an entire week, I couldn't go on deck without seeing something. So it began bothering me that here I was as far from civilization as you can get, and I couldn't not see evidence of civilization. It's civilization's waste. So I went back 2 years later after consulting with scientists and devising a sample plan and getting sampling equipment. And then that's when we found out that if you pull a net across the surface out there that's designed to catch zooplankton, little animal plankton that eat the plant plankton, the phytoplankton, these zooplankton nets, they will scoop up more plastic than plankton. It was 6 times as much plastic by weight as the plankton floating on the surface of the ocean. So we don't think of it as a food source, but in that area, in the deep ocean, animals are programmed by evolution to consume every scrap of material out there because it's such a what we call oligotrophic environment, an environment with so little food that animals have evolved to eat anything that they find out there. And so what we're finding is that all creatures in the food web now are consuming plastic. It's a food mimic, and nowhere in any scientific journal or any food web diagram will you see plastic listed as a food source. So it just goes to show you how far behind the curve the science is compared to our ability to pollute. The polystyrene is unique in that its most common form that we find polluting the ocean is the form in which it's used to deliver food. It's part of the food delivery system in many countries. The clamshell that has a hamburger in it, or the styrofoam cup that has coffee in it. These are foamed polystyrene, and the way that they do that is to inject gas into the plastic when it's in the liquid form and create these bubbles so that it acts as an insulator. it keeps cold things cold and hot things hot, and that I think is, in addition to the fact that it's a moisture barrier and things don't absorb into it, although that doesn't go for fat. If you have liquid fats, they will absorb into it. You can't get that yellow ring off a cup of noodles once you microwaved it. You know, the plastic is what we call lipophilic. It's oil loving, so it does absorb liquid oils, but water doesn't penetrate it. However, a study was done by Dr. Anthony Andrade looking at the breakdown of plastics in the marine environment, and he found that the ocean being cooler than the land and the heat that plastic absorbs being a factor in its breaking apart, that most plastics lasted longer in the ocean than they do on land, with the exception of expanded polystyrene or styrofoam. That structure of having these very thin walled bubbles in the material allows the ocean to penetrate and break those apart, so that of all the plastics, the only one that degrades faster in the marine environment than on land is expanded polystyrene. And what that means is this, that here you've got a plastic which in its solid form is heavier than water, but in its expanded form will float, being broken apart rather quickly and beginning to sink, so that when we get out into the eastern garbage patch of the North Pacific Gyre, we find very little styrofoam except for big fishing floats and things like that. We really don't find much in the way of expanded polystyrene. However, there's a sister to the eastern garbage patch. It's kind of like two eyes in a pumpkin that you've carved for Halloween. Way over on one side of this oval is a western garbage patch, opposite the eastern garbage patch, and that's near Asia. And it's a quirk of the currents that the Asian debris goes offshore, and our debris goes alongshore and down around the equator and back up. The point I'm trying to make is that it takes about 5 years for our styrofoam, polystyrene, expanded polystyrene, to float around down the California coast, past Hawaii, up around Japan and back to the eastern garbage patch. That is enough time for it to break down and sink. Whereas in the western garbage patch, when I visited there, I found big mats of expanded polystyrene, because it's less than a year it takes for the polystyrene to reach the western garbage patch from Asian sources of runoff and trash. So you have a completely different scenario in the western garbage patch, which is heavily polluted with polystyrene, and the eastern garbage patch, which is not. Now, another factor is that in terms of polluting the entire water column, I would think that polystyrene is probably going to be found more ubiquitously in the water column, because of the fact that, you know, let's say you've got a coffee cup that begins to break down in the ocean, and most of its little pores have been penetrated by water and broken apart, but there's still a few left, so that it begins to sink, but very, very slowly, and maybe gets suspended between layers in the ocean. So it's very likely that while, you know, all plastics will be found at all depths, you may have more penetration of different layers of the ocean by this plastic, which is inherently heavier than water, but is manufactured to have these bubbles that make it float. So in the degradation process, it's probably in all niches of the ocean environment, and that's not a good thing, because it's recently been shown that as it does degrade in the ocean, it releases harmful chemicals. Styrene is a mutagen and a carcinogen, and it's one of the monomers that make up the polymer. And you have to realize that when these plastics are manufactured, the polymerization process is never 100% complete. There's always some styrene left over in polystyrene, so that is being released into the ocean environment, as well as other chemicals that make it up. So it's not a pretty picture. We've always been taught, since we deliver food in it, that plastic must be inert. But it turns out it's far from inert and is perhaps implicated in some of the diabetes and obesity epidemic in the developed world.
What do you see as the main inhibitor of legislation getting passed, which will help mitigate pollution more so at its source, as you indicated earlier? Or how do we actually instill that this is a crisis?
Well, even if it's a crisis, it's considered in the economic paradigm as a rational trade-off. We have a deeply irrational rationality as part of our economic paradigm, in which a certain amount of cancers are okay if it propels economic growth. A certain amount of pollution is okay as long as it propels economic growth. A certain amount of mortality is okay as long as it makes life better for the majority. So you're faced with, well, I'll just give you an example of what you're faced with. There's very little plastic manufacturing in Honolulu, Hawaii, but there's one company that makes this expanded polystyrene. And when they suggested a ban on expanded polystyrene in Honolulu, Hawaii, the one company brought every single employee to the legislature when it was debating that bill. And the legislators were unable to bring themselves to vote for something that would affect the livelihood of these people who stood in front of them and told them that their livelihood would be affected by this legislation. So it's when you've got an economy that's based on growth in polluting industry, it's considered a rational trade-off to have it expanding and polluting versus the alternative, which is to slow the economy down and clean things up. So I believe plastic does need a timeout. I believe we need to rethink our use of plastic, but we cannot do it in an economic paradigm that demands unlimited growth as fast as possible to employ people in making goods that we don't desperately need, but that marketers can sell.